So this is the basic construction of n-channel JFET. Why it is called as n-channel? This bar, the entire bar is made up of n-type semiconductor. Entire bar is made up of n-type semiconductor, and current conduction, here the conduction of current, okay, is due to electrons with respect to the potential applied across gate and source. Okay, so with respect to the potential, the concept is same. So even in diodes, while designing or while drawing the VA characteristics of the diode, I have explained the concept behind diode. The same diode concept is applied here also, because the junctions are like PN junctions. Okay, other things are exactly same. So here across gate and source, we are applying the voltage. Now similarly at the output side also, drain and source, you have to apply some potential. Okay, that may be either positive or negative, depending upon that some potential will flow. So here I have considered the forward bias. This side is forward bias. So because of the application of forward bias, or I can say that since positive potential of the battery is connected to the P-type, okay, all the holes will be repelled by the positive terminal battery, and they're moving towards the channel. Okay, the holes are attracted by the electrons. Some of the charge carriers will be recombined, and some other charge carriers will not be recombined. Only the electrons will be there. And this side also I can say that see here there are more number of electrons. These electrons are repelled by the negative terminal battery, and they are moving towards drain. Drain is basically collector. It collects the charge carriers. So with the application of the input voltage or VGS directly, some the drain current or output current will be flowing through the device. Okay. So this is the n-channel JFET. Can you please draw p-channel JFET? Is it possible? I will try to explain p-channel then. Yes. P-channel, is it possible for you to draw? Yes, boys. What will you do for p-channel?
Ma'am.
Yeah, I will erase n-channel. Okay. Now can you tell me how will you draw p-channel JFET? What is the
gate
difference?
The gate will be of n-type.
Gate will be n-type, very good. But you have to start from the bar, like channel. Channel is made up of P, right? The channel is made up of P. So there must be one P-type bar here. Okay.
Yes, ma'am.
Yeah, P-type bar. Then other things are like it is exactly similar only. Right? If you understand the operation of n-channel JFET, it is very easy to you yourself can draw the p-channel JFET. You can explain the operation of p-channel JFET. It's very, very simple. Okay, why it is simple? Instead of n-type semiconductor, you have to make use of one p-type semiconductor. That is the only difference. I will draw that also now. See, so you have to use one p-type bar, p-type semiconductor, and n-type impurities are embedded like this. Okay. So this is your gate. This is N. N is also N. Both are connected together. Internally it is connected together, and a common terminal will be taken from the output. That is G. G. And here you know this side you see this is drain. This is drain, and this is going to be source. Okay. Now here you see. You can connect the battery in such a way that if you connect the positive negative, and here also positive negative, what will happen? That we can ensure. You want some current will be flowing. Maybe you can consider this as some VGS, voltage across gate and source. Am I correct or not? This side, what is the voltage? Voltage across drain and source. So it's a drain to source voltage. This side it is gate to source voltage. Okay, and source is grounded, commonly grounded. Now here with application of gate voltage, you know, if you apply forward bias, actually all electrons will be moving towards the positive terminal battery, because the electrons are attracted by the positive terminal battery, isn't it? Similarly, holes are all attracted by the negative terminal battery. So naturally the current will not be flowing. Okay, so because all the holes will be coming like this, output will not be flowing. So what you have to do? You have to reverse the polarity. Okay, so VGS must be negative. VGS is negative. If VGS is negative, current will be flowing. If VGS is negative, what will happen? See here, electrons are repelled by the negative thermal battery. Okay, so what will happen? All electrons will be flowing, or crossover. That is a depletion region. Few of the electrons will be combined by the holes, and recombination will be taking place. Okay, the charge will be neutral. The charge will be 0, and few electrons will be crossing towards the p-type bar. Okay, so mainly this is conduction is due to holes only, not due to electrons. And here again, these holes will be repelled by the positive terminal of the battery, and they are all moving towards the drain. So whole current will be flowing like this. Whole current will be flowing like this. And conventional current direction is equal to the direction of flow of electrons. So here also holes will be flowing, right? That will be positive. Here also you have to reverse. Polarity should be reversed. It's negative, positive. Then only conduction of current will be flowing. Conduction of current will be taking place. Here positives are attracted to the negative, so automatically flow will be there, right? So this is how we can explain the operation of n-channel JFET. Understood or not? And here also I can draw input characteristic curve as well as output characteristic curve, right? Input characteristic curve is a curve which is drawn between input voltage and input current, and output voltage output characteristic curve is drawn between output voltage and output current. Okay?